In today's video, we're going to have a look at smart materials. So this is probably going to, well, it is going to come up on your paper one, because paper one, the 2.5 hour paper, is materials, properties, and those sorts of things. So there's a few sort of smart materials you need to make sure you're aware of. So you've got thermoceramics, shape memory alloys, reactive glass, LCD, so liquid crystal displays, photochromic material, thermochromic material, and quantum tunneling composites. So what you need to know is basically what they are, what they can do, and then how they can be applied for like a real life scenario, basically. So before we get going, I just want to make sure you can identify the difference here. So I want to identify the difference between smart materials, composites, and modern materials. So we take smart materials. So that's a material that reacts with an external input. So a material that reacts to heat, or light, or moisture, or sound. So those are smart materials that are reacting to something. A composite is a material that comprises of two or more different materials joined together to enhance their properties. And then a modern material is a material that already existed that's been altered to improve its properties in some way. I've just realised my chair's making a noise. Hopefully the microphone's not picking it up. Okay. Now on the top of these, I've got links to YouTube videos, but what I'll do is I'll actually link those in the description of the video as well, so you can look at them. I won't show them on here because it will get copyright striked. So shape memory alloys. So most common example of that is nitinol. So what that is basically a thin strip, not sheet of metal that you can deform, bend, twist, shape however you want, and then it will change its shape depending on temperature or electrical input. So it might be that you bend it, then you put it in hot water or you heat it up and it will snap back into its original place, or it might be a little electrical current and that will snap back into place. Most commonly it's used in things like dental braces, self-closing windows, bone plates, and screws. So the reason why it's used in things like medical, bone plates, is because you'll put it in. So say you've broken your arm, you put it in, and it will slowly react to the temperature of the human body and snap back into the correct position. Same with like dental braces, is what you might do is slowly put electrical current through it, or apply heat to it, and it will slowly, because obviously they don't put braces in and just crank it up to like a million. They slowly over time tighten them, so it might be that you tighten it with like a very, very little electrical current or something like that. Next, thermochromic material. Now there's a couple of materials that we're not going to go over in this video, but the way you can really tell what it reacts with is the first word there. So thermo refers to heat. So thermochromic material is material that is responding to changing temperature. So you may have seen these in like, most commonly it's like the coffee cups that you pour hot water in and it changes colour. Like Coke bottles, Coke cans that change colour. You find some, I think, like Carlsberg, one of them, where they have like a little like decal down at the bottom. When it turns blue, it means, oh, it's the perfect beer drinking temperature. A bit of a gimmick for some things, but actually it does have some very, very good applications. One of the better ones is things like food packaging. So if you're heating up food, you can tell when food is the right temperature. You have like cooking pans that have like a red dot in the middle that will disappear when you know, oh, that's the perfect steak cooking temperature. I'm going to cook a nice steak right now. Okay, now I just want steak. Quantum tunneling composite. Now, because of programs like the Big Bang Theory, every time anyone says the word quantum, they think, oh, it's massively complex. That, in this case, really isn't the case. Okay, so quantum tunneling composite, essentially a lot of the time kind of looks like a rubber matting. Okay, so inside that rubber matting, what you've got is loads of like atoms, or like loads of like things in the middle. So when nothing's happening, they're so far apart that nothing is happening. Okay, what happens is that when pressure is applied, they get closer, so they can conduct, so electricity can flow through them. So you get an electrical circuit, electrical current. Sorry, I said it's atoms. Actually, it's metal like parts, basically. Sorry, I misspoke. And then if you press more, they get closer. So the idea being, it's not just like touchscreen; it's pressure pad. So you can apply more or less force. So it's not just on or off. It's a little bit on, a little bit on, a little bit on, full on sort of thing. Okay. A lot of it is used nowadays in things like sports clothing. So if you have like rugby players, American football players, boxing, so if you need to measure like impact to check injury, if it's like concussions, ISO in things like fencing, so they can check no one's cheating. Oh, you didn't stab me. Yeah, I did. So basically pressure has been applied, current will flow through, and then light turns on or makes a sound or a signal comes up on a computer and that type of thing. No pressure applied, nothing happens. Thermoceramics. Ah, look at that. I managed to get an F1 car in it again. Yes. So thermoceramics is a material, basically a ceramic material, obviously, that can withstand a huge amount of temperatures. It's very stable at very high temperatures. Because what will happen is it will disperse. Now, do watch this YouTube video because it is like mind blowing. Basically, this guy puts some thermoceramics in an oven so it's red hot, and then as soon as he takes it out, he literally picks it up with his bare hands. It's like you're looking at it like, oh my god, because what's happening is it's dispersing the heat so well. So it's basically ceramics mixed with metallic powders at high pressure, so they've bonded together, and basically means that it doesn't deform, it doesn't crack, doesn't become brittle, doesn't break under huge temperatures. However, they are very, very brittle, and you still have the problem of, like with normal ceramics, you get imperfections with things and they crack sometimes. That's just how it is. But they're used a lot in things like turbine jets and things like turbochargers in racing cars or brake discs because they can withstand huge amounts of temperature. But if it gets like impact, then it will shatter. But as I said, check that video out because it is literally like you look at it and think, oh my god, that's amazing. Photochromic material. So, like with thermo, which is heat, we've got photo, which is light. So, photochromic material reacts to UV light. So, most commonly, sorry, my chair is really making a noise, it's really annoying. Photochromic material reacts to UV light. So, most commonly, it is done on glasses. So, you got glasses that can turn into sunglasses. It's used a lot in welding goggles as well. So, there's done in welding in college. Welding produces a very, very bright light, so you got a lot of welding goggles that are clear, and then as soon as you start to weld and the spark comes on, the goggles will go completely black to protect you. So you've got reactive glass, which is different, so please don't get these two mixed up. So reactive glass is reacting to an electrical current. So when an electrical current is put through the glass, it's on, the glass is going to be clear, because what's happening is all of the molecules on the inside of it are lined up perfectly. And when they're lined up perfectly, it means you can see through it. As soon as you turn the power off, they scatter randomly, which is then why you end up with like this misted, foggy sort of like thing that you can't see in it. So it becomes like private. So it's used a lot in privacy windows. You see a lot now, because essentially it's replacing like blinds and curtains, particularly like modern hospitals. But also if you've got like skylights where you can't get a blind on it, it's used a lot in like certain like bathroom settings and like public restrooms, those sorts of things. So yeah, it's replacing because it's quite hygienic. Well, it is hygienic because you haven't got like a blind or a curtain that people have been touching. But very cool. But electrical current through it is on, so it's clear. You can see through it. Turn it off, and then you can't. LCD displays, liquid crystal displays. So this is basically how all your TVs and your smart screens and everything will be working now. So what happens is, have I got a thing? No, like I say, I thought I had a diagram on the next one. So you've got a crystal, and what happens is the light source will shine through it. Okay, and it's going to go through all these different filters to come to the filter that comes out and shows the displays on your screen. So what's happening is the liquid crystals, they actually force the light to twist and then go through a different color in your screen. Okay, so what will happen is your color filter is actually only red, green, or blue. But when you put your liquid crystal display in it, the light shines through it, it's twisted, and then it will go through and you'll end up with a different color. I'm pretty sure I've described that correctly. I've got it written down there, and I'm struggling to like articulate properly what I'm trying to say. Okay, so I just wanted to clarify. I didn't feel like I explained LCD crystals or liquid crystal displays, sorry, very, very well. So I wanted to get a couple of examples to show you. So before when I talked about it, the idea that what it did would cause the light to twist, is here's a little diagram to sort of show you what I'm talking about. But I wanted to just show you basically a really, really simple sort of definition of how it works. So on just literally how stuff works. So liquid crystal technology, basically it blocks out certain amounts of light. So there's two pieces of polarized glass, which are called substrate. That contains liquid crystal in the middle of it. So you've got substrate, a liquid crystal, and then substrate on the other side, and a backlight sends light through it. So the liquid crystal displays LCD, like the liquid crystals, sorry, I keep misspeaking, don't create light themselves, okay? They just affect how light passes through it. What happens is once you've got the substrate and the liquid crystals and then the substrate on the other side, like a little sandwich, an electrical current will determine how much light goes through, and then depending on how much current you have going through, depends on what color you have coming through. But what it will do is when you have electrical current, it causes, as you see on this diagram here, that's what causes the light to actually twist. So you've got, and then that goes into the color, and depending on, oh, what's going on? That depending on the amount of electric current you got going through there depends will alter the certain color that you have. So I just wanted to add that in there because I felt like when I was going through it in the PowerPoint, I did a pretty poor job of explaining it. So I just wanted to sort of clarify that a little bit. Hopefully that's made a little bit more sense. Next, phosphorescent material. So this most commonly is glow in the dark. So if you were ever little and you had sort of like those stars and the moon stuck on your wall at home, or like stickers or anything like that. So what happens is during the day absorbs light, and then at night it will emit the light again. It's used a lot in things like emergency signs, so fire exits, that sort of thing. It's not glow in the dark. It's not glow sticks, by the way. So please don't get glow sticks mixed up with phosphorescence. And then piezoelectric material. So what this does is it gives off a small electrical charge when you press it or you deform it. So it's used a lot in lighters. It's also used like pressure sensors and things like musical greeting cards. So when you open a card up and it starts singing. Also, if you have like one of those like mats that's like a piano mat keyboard sort of thing. But if you're thinking like sensible sort of things, it could even be that you say have pavements or roads that have piezoelectric material on it. So as cars and people are walking past it, it's storing up electricity that can then power, say, the street lights or whatever it may be. Okay, so we've got composites. So what we've got here are, so we've got glass reinforced polymers. So those are typically going to be used for, so much like fiberglass. So we've got carbon fiber reinforced polymers, which is your carbon fiber. That's just the full name of it. So it's CFRP. And then you've got glass reinforced polymers, which are very, very similar. So if you've ever seen fiberglass, essentially when you get it, it's like in a mat of literally loads of fibers wound together, woven together, sorry. I can't speak. And then you'll apply a resin to it, and then it will harden, and you put more layers on it, and it hardens, and so on. So carbon fiber is the same way, but it's got carbon fibers rather than glass fibers. So that's the key difference there. They're both incredibly lightweight and very tough. You've got tungsten carbide, which can withstand a huge amount of temperature. So it's used a lot in cutting bits because it will not deform under heat. So if you have certain drill bits and it gets too hot because you're drilling a lot of metal, it may deform and break a little bit, whereas tungsten carbide won't do that. You've got concrete and reinforced concrete. So when you have like concrete and you have the wire meshes inside of it to give it extra strength, or you have like tubing to give it extra strength as well, along with fiber cement, which is used a lot in roofing. And then we've got modern materials. So you've got high density modeling foam. So much like with your modeling foam that you used in the first year, which typically was the blue foam that's now grey, you can get denser material of that is actually very, very dense that you can like CNC route. Kevlar, which actually, interestingly, Kevlar is a brand name, like Sellotape is a brand name, or Hoover. So it's actually made of what is called aramid fibers, which has got very, very high cut and heat resistance. Obviously, most people know Kevlar from like cardboard or it's body armor. Okay, and yes, it's used for that as well, but it's also like protective clothing. So chefs can have it as gloves so they don't cut their fingers off. Same with like gardening. You can get punch-proof tires. It can be protective clothing for like biking, like motorbikes and those sorts of things. Polymorph, this is quite a popular, like common one, is it comes in granules, heat it up, doesn't require a lot of heat, like 60 degrees, and then you can like literally squeeze it into shape. So it's used quite a lot in like ergonomic grips of handles. So if you've ever had like a been on crutches because you broke a leg or sprained an ankle, things like that, what they might do sometimes is put polymorph around your handle so it's a bit more comfortable for you. And then you've got precious metal clay, which is clay. duh. But sorry, within that clay, what you're going to have is metal particles, like precious metal particles, so like golds and silvers, that sort of thing. So it'll be in there, and what happens is you'll make that clay into like a shape of jewelry, like a ring or whatever it's going to be, and because the metal particles are already in it, what you'll do is fire it up because it's like in a kiln because it's clay and need to. It will burn away the clay and then it will leave the precious metal left at the end. So you can make quite complex shapes by hand. So it's very arts and craftsy sort of thing. Okay, last thing. Questions on the screen. Can you pause the video? Have you got an answer in it? And then I'll put the answers. I will go through the answers with you in lesson. Any questions? Let me know, and I'll do my best to get back to you.